Okay, over the last year, we have learned 3 tools that we need to know for our test. Those 3 tools are taking a derivative, taking an integral, and solving. And so this video is designed to specifically review those 3 tools. This one's for the 89. Your document is structured in a way that there are 3 to 4 practice problems per tool. The idea being that I will use one of them, for example with derivatives, I'm going to use number 1 here, to review how to find a derivative. And then you have a few others that you can use to practice if you so choose. Okay, same thing with the integrals, same thing for solving. Okay, so 89s, they're to take a derivative, we're going to go ahead and use number 1 here. We are wanting to take a derivative of this function at x equals -3. 89s, you actually have multiple ways of finding this derivative, and I remember when we did this one in class, we had students who actually looked up other ways of doing it. If you are one of those students, you are more than welcome to still do this differently. For me, I tend to use my graph, and so that is what I'm going to review. This is what I would have taught in class. Okay, so we would go to our y equals, which is here, right, so that we can see our graph, and we'd plot, or we'd graph this function that we were wanting to take the derivative of. X squared minus e cubed times x. Right, so there's that function, square root of x squared minus e cubed times x. And we're going to go ahead and graph that function. Your window can be whatever you want it to be as long as -3 can be seen. So -3 is on this window here. I am going to go ahead and make that window a little bit bigger. I'm going to go -5 to 5 just to make sure -3 is actually on my window. And I'll go ahead and graph that. You could even go bigger, right? You could do -10 to 10, -20 to 20, doesn't matter. Okay, once it's graphed, we're going to go ahead and ask our calculator for the derivative. To do that, we go under F5, which is math there, and you'll see derivative down on number 6. And so it's going to say derivative at question mark, and you'll say, I want it at -3, please. And you'll type in -3, and it'll give you the -1.567253. Okay? Okay, if you would like to practice that, I've got 3 more functions here. You can see what their answers would be. Or if that was enough of a review, well, you can go ahead and move on to integrals. Okay, integrals, ladies and gentlemen, I'm actually going to use number 8 to review the integral process because it allows me to kill 2 birds with 1 stone. 1 to review how to plug in an integral, and 1 to review how to plug in absolute values. Okay? So, 89s, there are actually 2 ways. I find students kind of have a 50-50 split about which route they prefer. So I will walk through both so that whichever route you prefer, you have it reviewed. The first is similar to the derivative. Okay, we're going to go ahead and plot this function that we are wanting to integrate, the absolute value, the cube root of x cubed minus 1. 89s, your absolute value is under catalog, which is right here next to mode. If you go under catalog, you'll see ABS. We will then type in our cube root of x cubed minus 1. Cube root means to the 1/3. So you can see that there's our x cubed minus 1 cube root with the absolute value. Window again can be whatever I want as long as -2 to 4 is on it, which it is, -5 to 5, it's on there. So here's what this graph looks like. Okay, to do an integral, we're going to go under math again, which is F5. But this time we're going to do integrate, number 7 down there. It's going to ask you for your lower bound, which in this case is -2, your upper bound, which is 4, and it calculates it. Give it a little bit. That did take a little bit. Sorry about that. Okay, now it's going. And we get that 10.8018. Okay, so that's one way to do your integral. Some people prefer the graph. Others prefer their home screen. So I'm going to go ahead and go to the home. Okay, and to get this integral set up, you're going to go under calculus there, integrate, which is number 2. And you're going to go ahead and type in your functions. We've got absolute value, so catalog, absolute value, the x cubed minus 1 to the 1/3. We do comma x for dx, comma my lower bound, -2, comma my upper bound, 4. And when you hit enter, it'll take a little bit again. It's thinking. There it is, 10.8018. Okay? Okay, so that's an integral. If you would like to practice that process, we have 3 more integrals here, each with their answers, if you'd like to practice those integrals. Okay, last tool is solving. So solving, we've looked at this actually in a variety of different directions. It is the most broad tool, I would say, that we need to know, which is we use it anytime we're trying to solve an equation, right? And that equation could be anything. That equation could be the result of mean value theorem, or that equation could be the result of a word problem in some way, or maybe it's something you created to find relative extrema, or right, it's a very big idea. Anytime you are looking at an equation that you are trying to solve. So I'm going to use number 10 here. Number 10, we were given an equation, or maybe you wrote this equation, right? This could be maybe the result of some word problem, or I don't know, particle motion created this or something, okay? But you've got an equation, 2 things that are equal, and you are trying to solve for x. Well, given these 2 things that are equal, that I'm trying to solve for x, the first step, if I'm going to use my calculator, is to get this equation to equal 0. You can technically do that by subtracting the stuff on the left over to the right, or the stuff on the right over to the left, okay? But you've got to get it equal to 0. So in this problem, I subtracted the e to the x over, and I added 1. And now it equals 0. Once you've got your equation equal to 0, you're going to go ahead and take your calculator, and you're going to plug that equation that equals 0 into your y equals x to the 4th minus 3x squared minus e to the x plus 2. Okay, and I'm going to go ahead and make my window a little bit bigger on this one, just so I don't miss any zeros. So I'm going to go -10 to 10. You could even go -20 to 20 if you wanted. But when I graph this, I'm going to find that every time my graph touches the x-axis is one of my solutions. So in this particular case, I've got 4 places where this touches my x-axis. Okay? Okay, so to find each of those places, first one is here around -1.5. We're going to go ahead and do F5 for math, and we're going to calc our 0, since this equation equals 0. And it's going to ask you 2 questions, lower and upper bound. So if I'm trying to find that point at around -1.5, my lower than -1.5 would be like -3, right? That's lower than -1.5. And upper bound, higher than -1.5, would be like -1. And when I hit enter, it'll tell me -1.480. And then you repeat that process for each 0. So we found that one at around -1.5. There's another 0 here at about -0.5. So we're going to go F5, 0. What's lower than -0.5? Well, that'd be like -1. What's higher than -0.5? It'd be like 0. And it'll tell me -0.817579. Okay. And we do it again. Now we've got another point around 0.5. So 0, lower than 0.5 would be like 0. Higher than 0.5 would be 1. We get 0.414. And we do it again because we've got another point, looks like around 2 or so, so 0. Lower than 2 would be 1. Upper than 2 would be like 4. Hit enter and it'll tell me 2.096. And we do it again. Because we've got another point out here at like 8.5. So lower than 8.5 would be like 7. Higher than 8.5 would be 9. And it'll tell me it's at 8.535. Okay, so again, this tool can be used anytime you are solving an equation. You've got an equation on your paper, you are trying to figure out what x would have to equal, then that's where solving kicks in. You get your equation to equal 0, and then you calc your zeros every time you touch the x-axis. There are 2 more problems if you'd like to practice this a little bit more. Answers can be seen, but that's your third and final tool.